is the part 2 of this is solving of systems of linear equation using the substitution method. So number 6, we have here x minus y equals 3 and then 7x plus 2y equals 3. Okay, so this one here, as you can see, the first equation actually, it's easier to use this one as our equation for the substitution because it's easier to separate a variable here. Okay, we have here x minus y equals 3. So what do we do here? Again, our goal is to separate one variable. It's not always required to be y or x. Again, it can be either of the two. So however, on this one, I guess it would be easier if we will just transpose the negative y to the right. And then if we will transpose negative y to the right, what will happen? X now will be separated. I mean, x will be alone. So x equals negative y will become positive and then plus 3. So now we already have a separated variable, and in this case it's actually x. So the other hand, let's use the other equation for the solving. Okay, so we have here 7x plus 2y equals 3. Okay, so again in sense we just have to rewrite this. However, as you can see, x equals y plus 3, right? So this time, instead of writing x, I can already write what? I can write now y plus 3 and then plus 2y. I just copy the 2y and then equals 3. Okay, next one. What do we do? As you can see, okay, before we proceed, as you can see, we don't have any more the variable x. What we only have is the variable y, and since it's only one variable, we can solve it already, like what we're doing with solving of linear equations. So distribute 7 times y and then 7 times 3. Okay, let's start first with 7 times y. 7 times y, of course 7y, and then plus 7 times 3, that's gonna be 21, and then plus 2y equals 3. Okay, what do we do next? Again, just put all those with variables together and then those without together. So in this case, both 7y and 2y are already on the left side. So let's just try to combine them. 7y plus 2y, that's gonna be 9y. And then plus 21y, sorry, plus 21 is equal to 3. Again, our goal is what? To make the y solo and positive. Okay? So let's transpose the 21 to the right. What will happen? 9y is equal to 3. And then what will happen to positive 21? It will become negative 21. So now we have 9y is equal to 3 minus 21. That's going to be negative 18. Okay, negative 18. And then what do we do next? Again, divide both sides by 9 to solve for y. So y is equal to, what is negative 18 divided by 2? Sorry, divide by 9. That's going to be negative 2. Okay, but are we already done? Okay, actually not yet, because we just only have the variable y. Now so the next question would be, what is the value of x? Again, we can use either of the two equations here, but I guess it's easier to use the first equation. The first equation is x minus y is equal to 3. Okay, what do we have now is only the y. So we will just substitute the value of y. So x minus, now what's the value of y? Negative 2. And then equals 3. Next one. So x, what will happen here? Negative and then times negative 2. That's gonna be positive 2 and then equals 3. How do you solve for x? What do we do is we transpose the 2 to the right side. And what will happen? X is equal to 3. The 2 will become negative. So x is equal to 1. So our solution would be what? 1, comma, negative 2. Okay, again, x, comma, y. X is 1, y is negative 2. Okay, next example, number 7. Okay, so I guess this one is quite different already. As you can see, there is no coefficient here. I mean, there is no variable here to have a coefficient of 1. Here we have 3, 2, 9, 8. So there is no coefficient of 1. So what do we do? Again, we can select either to be used for substitution. So let's say we use the first one for substitution. So we have here 3x plus 2y equals 7. What's our goal again? Our goal is to separate one variable. Okay? Let's say for example, we choose to separate the variable y. How do you separate the variable y? Of course, you have to transpose the 3x. So what we have now is 2y is equal to negative 3x, right? Because if it's transpose, and then plus 7. Now, are we done already? Not yet, because again, our goal is to solve for y, right? I mean, to separate the variable y. Is it already separated? Not yet, because we still have here the 2. How do we cancel the 2? I will divide this by 2, and then I will also have to divide the other 2 by 2. So what we have now, y is equal to negative 3x over 2. Nothing can be cancelled here. It's not divisible. And then plus 7 over 2. You can just retain them as a fraction because we cannot simplify them. Okay. Now, what do we do next? Again, this time we already have a separated variable y. The next thing we have to do is use the other equation now. We have 9x plus 8y equals 22. Okay. Again, in sense, we just have to rewrite it. So 9x plus 8. Okay, now, instead of writing y, what do I write? I'll put here the negative 3x plus 2 and then plus 7 over 2 and then equals 22. Okay, next. Let's continue solving. 9x. Okay, let's start first with this one. Okay, again, this is distribution. So let's start first with 8. 8 times negative 3x over 2. I will write here. Okay, what is that? Okay, for us not to be confused, what do we do is, again, what's the rule of multiplication of fraction? Numerator to numerator, denominator to denominator. Okay, that's the one I taught you before. Sir, but your 8 is not a fraction. Well, we can make it as a fraction, right? I can put here 1. Now, what is 8 times negative 3x? That is negative 24x. And then, what is 1 times 2? Again, numerator to numerator, denominator to denominator. 1 times 2, of course, that is 2. However, this time, this 1 can still be simplified. Negative 24x over 2 is what? Negative 12x. So I can put here minus 12x. Next one, 8 times what? 7 over 2. What is 8 times 7 over 2? What do we do again? I can put here 1 as denominator and then follow the rule. Numerator to numerator, what is 8 times 7? That is 56. And then 1 times 2, of course, that is 2. However, again, we can still simplify this. What is 56 divided by 2? That is 28. So, that's positive, right? Because 8 times 7 over 2, that's positive. So, plus 28 here. And then I'll just copy the equals 22. Okay. Next one, what do we do? Just combine them. 9x and negative 12x, they both have the x, right? So we can combine them. What is 9x minus 12x? Of course, that's going to be negative 3x and then plus 28 is equal to 22. Okay. Actually, we can do a lot here, like transposing 28 the other side, or we can also transpose the negative 3x to the right side. And I suggest we can just transpose the negative 3x to the right side. So why? Because this is to make the x positive. So if I'm going to put the negative 3x to the right, what do we do with the 22? I have to put it on the left side. So what will happen now? So on the left side, we still have the 28. And then the 22 will become negative 22 is equal to the negative 3x will become positive 3x. So what we have now, 28 minus 22, that's 6 equals 3x. Are we done already? Not yet, because we need to solve for x. So divide by 3, divide by 3. So 2 is equal to x, right? Or using the symmetric property, x is equal to 2. Okay, but are we done already? Not yet. We only have the x, but we don't have yet the value of y. Okay, so how do we solve for y again? We can use either of these two equation here. So let's use the first one because it's only a smaller number. There's only smaller number there. So we have here 3x plus 2y equals 7. And then what do we do? But this time what we only have is the value of x. So I'll put here 3 times 2. Again, x is equal to 2. And then plus 2y is equal to 7. 3 times 2, it's gonna be 6. And then plus 2y is equal to 7. What do we do to solve for y? Make it solid and positive. So I have to transpose the 6 to the right side. So 2y is equal to 7 minus 6, right? And then now we have 2y is equal to 1. How do you solve for y? Divide this by 2, divide this by 2. Now, y is equal to 1 over 2, right? It's only 1 half. We cannot simplify it anymore unless you're asked to convert it into decimal. But our answer now would be what? Again, x comma y. What's the value of x? The value of x is 2. So 2 comma. The value of y is 1 half. So 2 comma 1 half. This is the solution. Okay. I hope we still get it. So let's have more example here on the next one. This one here. Okay. So we have 3x minus 2y equals 8. And then we have also 4x plus 3y equals 5. Okay. Again, we can select either of the two to separate a variable. Okay. I believe maybe let's use the first one here to separate. So we have here 3x. Oops. How do I erase this thing? It's hard to erase here for a while. Oops, what happened? I'll just get the eraser. And there you go. Okay, let's go back to our pen. Okay, so 3x, what? We have 2y, and then equals 8. Again, take note, our goal here is to separate a variable. And I guess it's easier to separate here on this one, the variable y. So how do I separate a variable y? And actually, again, still make it solid and positive. So since y here is negative, I'll just transpose it to the right. And then, if I'm going to transpose the y to the right side, of course, I have to take away here the 8. I have to transpose the 8 to the left. Now what will happen? What will happen? We have now 3x will remain, and then 8 will become negative 8 is equal to the negative 2y will become positive 2y now. Okay. So how is y already separated? Not yet. How? But how do we separate y? Because y is not yet solo, right? So how to make it solo? Divide by 2. So if I'm going to divide this by 2, I also have to divide everything on the left side by 2. Now what will happen? 3x over 2 minus 8 over 2. Okay, 8 over 2, I guess we can simplify this. What is 8 over 2? 8 divided by 2 is 4. And then is equal to, cancel the 2 here, cancel the 2. So equals y. So in other words, y is equal to 3x over 2 minus 4. Now, we already have a separated variable, so we can continue. Let's use the other equation. 4x plus 3y equals 5. So I'll just write here 4x plus 3y equals 5. Okay, so let's just try to rewrite. So 4x plus 3. Okay, now this time, as you can see, a while ago we separated the variable y. So this time, instead of writing y, I can write here 3x over 2 minus 4. Okay, and then is equal to 5. I hope you can still follow. Now let's do this. So what do we do here? So we have now 4x plus. Okay. Again, this time we have to distribute again. Distribute. So what is 3 times 3x over 2? So again, numerator to numerator, denominator to denominator. I just put 1 for the 3. I mean, I just put 1 as the denominator of 3. So what do we have now? 3 times 3x, obviously, 9x over 1 times 2 is 2. So I can put here 9x over 2. And then the next one is 3 times negative 4. What's that? I guess there's no need to explain that one. 3 times negative 4 is negative 12. And then I'll just copy equals 5. Okay. Now what do we do? We have here a fraction, right? We have a fraction. I hope you can still remember the one we do last time. When we have fractions in solving linear equations. What we do actually is we get the LCM, right? And actually in this time, it's so easy to find the LCM because there's only one denominator. What's the denominator here? It's 2. So what we can do is we can multiply everything now with 2. Just multiply everything with 2. Since again, this is the rule when you just have one denominator. So what will happen now? So 2 times 4x, that's gonna be what? 2 times 4x, what's that? That is 8x, and then plus 9x over 2 times 2. I just have the 9x. And then minus 12 times 2, that's 24. And then equals 10. Okay, so for those who might be confused, because this is, I guess, a different approach, right? So I will just use the other approach last time. So we have here 4x plus 9x over 2, right? Okay, I'll just try to use a different approach to further explain this. Again, our LCM is 2, right? Or LCD. So I have to make everything into a denominator 2, right? Everything over 2. So now 4x is a whole number. What's the denominator of 4x? 1. 12 is a whole number. What's the denominator of 12? 1. 5, denominator 1. So the same procedure we're doing last time. What is 2 divided by 1? It's 2, right? Times 4x, that's gonna be 8x. Next. Do we still need to convert the 9x over 2? No need, because its denominator is already 2. So I'll just put here 9x. This one here, 2 divided by 1. What's that? That's 2, right? Times 12, that's 24. And 2 divided by 1, that's 2. Times 5, that's 10. And we can already just disregard the denominators. That's why we have here 8x plus 9x minus 24 equals 10. Okay? I just wanted to say that these two here are just the same thing. So let's continue now. Now we have here 8x plus 9x. What's that? That's gonna be 17x. And then minus 24 is equal to 10. And then what do we do again? We need to solve for x. right? By separating it and making it positive. So what we can do here is to transpose the negative 24 to the right. So we have now 17x equals 10 plus 24. So 17x is equal to 34. Divide both sides by 17, right? This is to cancel the 17. So now x is equal to 2. But are we done already? Not yet. We don't have yet the value of y. How do we solve for y? Let's use either of the two equations. Maybe let's use the first one. So we have here 3x minus 2y is equal to 8. What we have now is only the value of x. Okay, so 3 times, what's the value of x? 2. Minus 2y is equal to 8. So 3 times 2, it's going to be 6. Minus 2y is equal to 8. Okay, how do we solve for y now? Okay, I guess it would be much easier if I'm going to transpose the 2y, oops, transpose the 2y, I mean the negative 2y to the right side, and then transpose the 8 to the left, so that I can have a positive y. So 6 will retain, so 6, 8 will become negative 8, and then is equal to 2y. I hope you can still follow this one. So 6 minus 8, obviously that's negative 2, equals 2y. How do you solve for y? Divide this by 2, divide this by 2. So negative 1 is equal to y, or simply, or I mean using symmetric property, y is equal to negative 1. So our final answer, or the solution, would be, again, x comma y, right? What's the value of x? 2. What's the value of y? Negative 1. So this is our final answer here. 2 comma negative 1. Okay, we're down to our last two example. Next one is negative 2x minus y equals negative 9, and then 5x minus 2y equals 18. So actually, as you can see, on the first equation, there is a variable with a coefficient of 1. I mean, it's easier to separate, right? So I'll just copy. So negative 2x minus y is equal to negative 9. Sir, how can you easily separate a variable here? I mean, as you can see, y is easy to separate. How? If I'm going to transpose negative y to the right side, and then if I transpose negative 9 to the left side, what will happen? Negative 2x will retain, and then negative 9 will become positive 9 is equal to the negative y now will become positive y. Okay, so we already have a separate variable, or using symmetric property, y is equal to negative 2x less 9. Okay, next. So we will use the other equation as our main equation here. So we have 5x minus 2y is equal to 18. So just rewrite it. So 5x minus, what's the value of y again? Y is just the same thing with what? Y is negative 2x plus 9. So instead of writing 5x minus 2y, I can write 5x minus 2 times the y is negative 2x plus 9 is equal to 18. Okay. Again, we just replace the y by this thing here. Okay, next. So 5x. Now, what we do is we have to distribute. So, okay. So negative 2 times negative 2x, obviously negative times negative, that's going to be positive. And 2 times 2, that's 4. Oops. That's going to be 4. And then 4x. Okay. Don't forget the variable x. So negative 2 times negative 2x, that's positive 4x. And then negative 2 times 9, that's going to be negative, right? Because there's only one negative sign. So negative 18. And then is equal to 18. I hope you can still follow. So now, what do? We can combine these two, right? because they're just in the same side. 5x plus 4x is gonna be 9x minus 18 is equal to 18. What do we do next? We transpose the negative 18. So we have now 9x is equal to, what will happen to the other 18 on the left side, the negative 18? It will become positive 18. So 9x now is equal to 36. How do you solve for x? Divide both sides by 9. So x is equal to 4. But we still have to solve for value of y. So let's use the first equation. So we have here negative 2x minus y is equal to negative 9. Okay. Maybe let's use the second one because there's a lot of negative sign here. Again, you can use either of the two. However, my preference sometimes would be to just use the other one with less number of negative sign. This is to have an easier calculation. So we have here, so what's the value of x? X is 4. So we just have to replace the x with 4. So 5 times 4 minus 2y is equal to 18. So 5 times 4 is gonna be, of course, it's gonna be 20. And then minus 2y is equal to 18. So how do we solve for y now? Okay, of course, negative 2y here will be transposed to the right side, and then 18 to the left side. What will happen now? So 20 minus 18 is equal to 2y. So 20 minus 18 is going to be 2, and then is equal to 2y. To solve for y, just divide this by 2, divide this by 2. So 1 is equal to y, or simply, by using symmetric property, y is equal to 1. So our final answer now would be what? Again, this is 1. Sorry for the writing. Okay. So again, x comma y. The value of x is 4. The value of y is 1. So our final answer would be 4 comma 1. Okay. Now we're done to our last solving. Okay. So we have here, toward the number 10, negative 4x minus 2y equals negative 40. And then 6x minus 5y equals 12. Okay. I guess this one might be a bit harder, right? Because we don't have here a variable with coefficient of 1. But this one here, considering the given, the first one could be easily used for the substitution. So we have here negative 4x minus 2y is equal to negative 40. So which one is easier to separate? On this one, actually, my suggestion would be, if there are two with both coefficient, just select the other one with the smaller coefficient. So it's 2y. So let's separate the y. So how do we separate the y here? Of course, since the y here is negative, transpose it to the right. And if you will put the y to the right side, of course, you have to take away or transpose the other one on the left side. So we have now here negative 4x. Okay. Then the 40, or the negative 40 will become positive 40 is equal to the negative 2y will become positive 2y. Again, I hope you can still follow the transposition here. I just transpose the negative 2y to the right and negative 40 to the left. Again, why did we do that? Because our goal is to separate the variable y this time. But is the y already separated? I mean, completely separated? Not yet, because we still have the coefficient of 2. So how do we cancel the 2? So we have to divide this by 2, and then if we do that on the right side, we also have to do that on the left side here. So over 2 over 2 there. So I guess this one can be simplified, right? So negative 4x plus 2, negative 4x divided by 2, it's gonna be negative 2x. And then plus 40 divided by 2, it's gonna be 20. is equal to, okay, this time here, the 2 will be cancelled. And there you go. So, or we can actually write this as y is equal to negative 2x plus 20. I hope this one is still clear with you. Okay, this is our last example already. So, if that's the case, let's use the other one as our main equation. So we have here 6x minus 5y is equal to 12. So the one we will replace is the y, right? So I'll just put here 6x minus 5. Again, instead of writing y this time, let's put here negative 2x plus 20 and then equals 12. Okay, so this time we will have 6x. Okay, negative 5 times negative 2x. Okay, negative times negative. That's gonna be positive. So 5 times negative, sorry, 5 times 2x now would be 10x, right? So positive 10x because it's negative times negative. Next one would be negative 5 times 20. Okay, so negative times positive, that's gonna be negative. So 5 times 20, that is 100, is equal to 12. Now, what do we do? What do we have next is, okay, so we have now 6x plus 10x is gonna be 16. Okay, 16x, don't forget the variable x, minus 100 is equal to 12. How do we solve for x again? We have to transpose the negative 100 to the right side. So 16x is equal to 12 plus 100. Again, negative will become positive. So 16x is equal to 112. So how do we solve for x again? Divide now both sides by 16. Okay, so x now will be, okay, maybe let's show the long division of this one, okay, 3 to follow. So 112 divided by 16. What do you think is our answer here? Um, can I put here 7? Let's try 7. Because, sir, why did you start with 7? Because 7 times 6 is 42. So there's a high chance, right? So 7 times 6 is 42. So 2 carry 4. 7 times 1 is 7. Plus 4 is 11. See that? So x is gonna be 7. Okay? So we already have the value of x, which is 7. Now, what we need to do is to solve for y by using again either of the two equation. However, as you can see, the first equation, all of them are negative, so it's gonna be a bit harder. So let's just try to use the second one. So we have here 6x minus 5y is equal to 12. What's the value of x again? X is 7, so just replace x. Then 5y equals 12. Again, your goal here is to solve for the value of y. What is 6 times 7? That's gonna be 42 minus 5y is equal to 12. Okay, the 5y here is negative, right? So to make it easy, I just have to transpose it already on the right side. And then if we will put the variable on the right side, we put those without variable now to the left side. So we will have now 42, because 42 retain eh. So then the 12 now will become negative 12 because it was transposed, is equal to the negative 5y will become positive 5y. Now we have here 42 minus 12, that's going to be 30, is equal to 5y. How do we solve for y? Divide by 5, divide by 5. So what's 30 divided by 5? It's going to be 6, is equal to y. Or using symmetric property, y is equal to 6. Okay, so our final answer should be again in a form of x comma y. So it's gonna be x is 7 and y is 6, so 7 comma 6. That's our final answer. So again, regarding this topic, we have two videos of this. This is the part 2. So what I want you to do is like to please try to practice answering first on your own. It's like you can pause the video, and then you can just check by after you answer it on your own. Okay, so I hope this one will be able to help you in understanding on how to resolve systems of linear equation using the substitution method.